So the second question that we have is another question involving graphs. We have been given a volume versus temperature graph for a gas, and the gas is initially in the state A, it goes to B, comes back to C to its original volume, and then comes back to A via isochoric process. Now we need to find out the heat absorbed by the gas in the above process. The first thing is that you should very well know how to interpret graphs. It is actually very important. I've seen many questions which can be solved easily with the help of graphs, and are really very difficult to solve if you keep on using the formulas. So it is best if you know how to interpret graphs properly. Here we have a VT graph. We need to find out the heat absorbed in the above process from A to B to C to back to A. So the heat absorbed will be equal to delta U plus W. Now the change in internal energy is 0 because the gas is coming back to its original state, that is final state is equal to initial state, therefore delta U is equal to UA minus UA is equal to 0. Now therefore Q is equal to W. So we have one way to solve for the heat absorbed, that is equal to work done by the gas. Now we can easily see that for the path CA, work done by the gas is 0 because there is no change in volume of the gas. The volume of the gas is constant to be V0 in this process, therefore work done by the gas in the whole process is equal to work done AB plus work done from B to C plus work done from C to A. This has come out to be equal to 0. So we now need to find out work done by gas from A to B and then work done by gas from B to C. Now A to B is a isothermal process. You should remember the formula for finding out the work done in all the processes. Work done by the gas in an isothermal process is equal to nRT ln V final upon V initial. Therefore this is for an isothermal process in which the temperature is constant. Therefore let us write this down over here. Work done from A to B is equal to nR T naught ln V final is 2 V naught, V initial was V naught. This is equal to nR T naught ln 2. So we have the value of work done by gas from A to B. Now B to C, look carefully, this line passes through the origin. Therefore this is of the format, the equation of this line will be of the format V is equal to some K dash into T. Now we know that PV is equal to nRT. So nR upon P into T. Now since this is an ideal gas, therefore it must follow this also. Therefore this constant K dash is nothing else but nR upon P. This is constant, therefore nR upon P is constant. Therefore the pressure of the gas is also constant. So you must keep in mind that a line passing through the origin in a VT graph represents a constant pressure process. That is isobaric process. This is a isobaric process. So for an isobaric process, we know that the work done is equal to P into the change in volume of the gas. So we need to find out either PB or PC. So in this question we need to find out PB now. So for finding out PB, we see that in the process AB is a isothermal process. In an isothermal process we have PV is equal to nRT. Since temperature is constant, therefore this term is constant, therefore P initial V initial is equal to P final V final. Therefore we have P naught V naught, that is the pressure and volume at A given over here. This is equal to PB into 2 V naught. Therefore we get PB is equal to P naught by 2. Therefore we now have PB, that is equal to P naught by 2. So PB is equal to P naught by 2. Therefore the work done by the gas in this process will be equal to pressure, the constant pressure of the isobaric process, into V final minus V initial, that is equal to V naught minus 2 V naught, that is equal to minus V naught. You can, if you do not remember that, you can always remember it like this, that pressure into the change in volume will give you the magnitude of the work done by the gas, and you apply positive or negative sign depending on whether the volume of the gas is decreasing or increasing. If the volume of the gas is increasing, then it is doing positive work, otherwise the work done by the gas will be negative. In this case the volume of the gas is decreasing, therefore the work done by the gas is negative. Therefore work done by the gas in the process B to C comes out to be equal to minus P naught V naught upon 2. For the process A to B, we had it as nR T naught ln 2. Now we also know that P naught V naught is equal to nR T naught. For this state, writing the equation of state for state A, we get P naught V naught is equal to nR T naught. Therefore, nR T naught can be replaced by P naught V naught. This becomes equal to P naught V naught ln 2. Therefore, the total work done by the gas W is equal to this plus work done by the gas from C to A, which is 0. Therefore, W comes out to be equal to P naught V naught ln 2 minus 0.5. This is equal to 0.193 P naught V naught. So our final answer for the heat absorbed by the gas in the process comes out to be equal to 0.193 P naught V naught. So what we learned from this question was that you should remember all the formulas for the work done by the gas in all the processes, at least isothermal, isobaric and isochoric, and you should know how to interpret graphs.